Hello, welcome back to Math Time with Professor Prime. And I am your host, as always, Professor Prime. So, I want to talk about math and art. For me, math is beautiful and there's a lot of art in it, and I don't feel like that gets talked about nearly enough. Um, so, I wanted to talk about that. And I wanted to talk about things on a base level and then kind of allude to how crazy it can get on a larger level and how there is art in the way you solve a problem as well. So I've said it once, I've said it twice, I've said it a million times. Math is a language, it's a way to communicate, and so you can really play around with that. And I feel like in order to get the most out of math and in order to like really build your skills, you want to pay attention to the vocabulary that's involved, as well as, any rules that you might have, i.e., certain properties or formulas that you might encounter. And once you do that, knowing what they actually represent and then using those tools that you're building to solve problems. And in that process, you're going to be doing a lot of art, even if it doesn't feel like it. Because to me, with art, it's about expression. It's like, an artist and the person viewing that art are crucial to this. So I feel like with math, you have a couple things, right? Like you can figure out how you want to solve things, how you want to approach it mathematically. And once you do that, also, does that message get across? Because, right, you are sending a message when you're doing math. And one of the things that I tell my students is that, right, they're telling me a story, right? They're weaving me a tale. They are painting me a picture. The destination's important, but so is the journey. It's important to see how you got there. And so while you're looking through things, it's like, well, how did you get there? Does it make sense? And I think with math, there's more than one way to make sense. There's more than one way to get across the message. And so I wanted to start by talking about like addition. Just because even on that base level, I feel like there's a lot that you can do, and I want to talk about that and like basic algebra in general in another video or a set of videos, depending on how that shapes up. But I feel like we can talk about a couple things here, and that's going to be okay. So let's say I have one here, right, and I have two here. I bring them together, add them up, I get three. Now I have two here, and I have one here. I bring them together, I still get three. Addition is nice like that. Things commute. They go the same way backwards and forwards. They represent the same quantity. And so you can play games with that. Multiplication is also nice as a result. And so, like I said, I want to get into the properties in another video to see if that like helps break things down for people. But I think it's important to talk about what I just talked about in this video, which is that were they were, sorry, but those are two different ways for me to express those sums and what those sums represent, which is three. And I can play that game, right? With a lot of different things. So, say if I had something like 25 and 8, and I want to find the sum of those two. Now, that's easy enough. It's 33. But what if I was learning that? And what if I wanted to see different ways that I can approach it? Well, one of the different ways that I'll start with is the more traditional route. And I will do some more things on a whiteboard when I get one in the near future. For some other videos, sure, but things like this that I'm doing right now too, because I feel like it could come in handy. So 25 and 8. Like one of the ways you would typically see that is, you have 25 plus 8, and you can look at 5 and 8 and see that, hey, they add up to 13, and then carry that 1 and add that 1 to the 2 and get 33, right? That's one way. And you don't have to do it that way, though. What if there was some larger numbers and I didn't feel like necessarily dealing with that? Um, well, what could I do? I can manipulate things. I can say that, hey, 25, okay, I'm okay with that. And with 8, what if I break that up so I can use that better with the 25? I could say that 8 is 5 plus 3, so I can rewrite things as 25 plus 5 plus 3. And at 25 and 5, I'm like, hey, that's nice enough to add. I get 30, and so I can have that 30 plus 3. And that would give me 33. I could also look at that 25 and then 8 and say, hey, I can figure out what 8 and 5 add up to. So maybe I want to break things up. So maybe I want to break up that 25 into 20 plus 5, right? Because the idea is like with a sum, if I can simplify that, then I'm saying my sum is this number. So I can go back and forth. Because when I'm saying that something is equal, I'm saying it's the same thing. So if I take that 25 and I break it down to 20 plus 5, I can then have 20 plus 5 plus 8. And 8 plus 5 is 13. So I can play that game and then say, hey, I have 20 plus 13, which is also 33. So it's like, well, there's three ways to get 33 there, but it's not limited to that. There's so many different ways I can play that game. And, I could be doing some things for fun, but I could be doing something in a testing situation. And I want to see, hey, what works for me? What do I want to get across? And I think that's amazing. There's so much power in that. There's so much that you could do. And that's just with addition. And the whole thing is, right, like you take numbers, what we come to think of them as, you start building these properties, you start expanding. And with algebra, it's all about representation. And you build from there. From algebra, you can just start going off in some different directions with that, and it just all builds off of itself. And I think that's amazing. And then there's calc. So I don't want to get into it full fledged because then I'll never shut up about it. But with calc, if there's someone either taking that now or taking that in the future, the key to calc is knowing that you need to know the things that came before it. You need to know algebra. And if you're doing the more traditional calc, you trig to go along with that. If Either way though, the point is that you'll need to know the things that came before it. Because what I've experienced is a lot of people get to calc and they'll get lost on this or that. They might memorize some of the rules that come into play with calc, but don't know how to use them properly. And the idea is that for calc, you need to know your algebra. If you don't, it's like trying to write an essay when you don't know how to compose a sentence. But then once you do know that algebra, you can start to get into the art of it because you can start to dissect things. You can start to look at some problem, like say if I was finding like the derivative of some function, which that's another thing for another video. But the idea is like I could look at the kind of function that I had, and based on that function, I can apply certain rules to it. And this is like right off the back, but if I wanted to see if I can more accessibly solve it, I might want to rewrite my problem. And knowing how algebra works and how to rewrite things is key. And I think that's amazing. And with problem solving in general, you could argue that there's a lot of art in it because what you could do is when you're problem solving, right? You're looking at a problem, you're reading it, you're asking yourself if you understand what's being asked of you, and then what are you doing? You're devising a plan based on what's being asked of you, but also what you know. And I think that's where the art comes into play because if you're looking at something, it's like, well, how can I solve it? Unless it like really, really got strict and said to solve it a different way, it's open to interpretation. And maybe I'm looking at that situation and maybe an algebraic approach works better, but maybe a visual one might make more sense in certain situations, and then I can get geometry involved perhaps. But the idea is like there's so many different ways you could do it. And one of the examples that I've talked about on this like platform and in general, and I'll probably talk about some other examples at another time. But the idea is like, well, what if I'm getting paid? And let's say I'm getting paid $10 an hour, and I want to figure out how I'm getting paid. If oh, wait, look, sorry, at 50 hours, like mm, maybe just 40, because then we can get into overtime, and that's a whole nother thing. But the idea is like I know that I'm getting paid $10 an hour, and I can like do things numerically in my head. I can do that by adding $10 per hour. I can take advantage of the fact that multiplication is repeated addition, so I can start to use that to form algebra if I wanted as well. So I can take that problem and I can express it algebraically. I could say that I have the amount that I'm getting paid, and that's dependent on how much I'm working and how much I'm getting paid per hour. And so I can say that what I'm getting paid is the dependent variable, and I can use y to represent that, which is fine. I don't have to use that, but in this case, I can because it's like it's not so much the variable; it's what it represents. And then I could say, hey, what about how I'm getting paid, how much I'm getting paid? I can view that as an independent variable within its own sort of thing, and I could view that $10 per hour is the rate of change. So I can construct an equation out of that. I can say y equals 10x, and I could use that to say something about the amount of hours that I'm working. So if I do it for 40 hours, I can substitute 40 into x, and so I have y equals 10 times 40, or y equals 400. And what that statement is saying is that, well, my pay will be $400 if I work 40 hours because of how we define things. And I think that's amazing. And I think that's great. So to me, that's just scratching the surface. But there's so much more out there, and I urge you to explore because you can express yourself in so many different ways. And I remember when I was younger, people used to like the way I prove things, like mathematically. It's because I kind of took people on a journey. I would, talk about what things were, and then I would establish things more formally. So I took you on that journey, and that's something that I do feel ends up extending into my teaching style. I tend to talk about what something is and then talking about like the math behind it, the tools that you'll need to say something about that on a larger level. And so I think that's amazing. So yeah, I hope this helps jumpstarts someone on this. But yeah, Professor Prime out.